We're constantly hearing about artificial intelligence, right? These
Yep.
amazing, huge software systems running on, I don't know, colossal servers. The narrative is always about this unlimited digital expansion. But here's the thing that sort of runs counter to that. The biggest bottleneck in this whole AI boom, it isn't the software. It's not even raw processing power. It's physical memory. It's RAM. And that invisible bottleneck is quietly rewriting the price tag on almost everything you buy. Okay, so let's unpack that. The demand from AI data centers for this very specialized high-speed hardware has created a massive supply shock, a huge one, for a component that, frankly, most of us never think about. We're talking about the price of RAM chips for computers more than doubling.
And in some cases, actually tripling.
Tripling in just a few short months. This isn't just some corporate IT problem, It's a global inflation pressure point hiding in plain sight.
Right. And to really get the impact, we have to start with the component itself. We're talking about random access memory.
Yeah.
RAM. The easiest way to think of it is as the short-term working desk for any digital device. It's holding all the data your device is actively using right now. Your open apps, that video you're streaming, the spreadsheet you're working on. But the key is that RAM is volatile. When you turn the power off, poof, the desk is instantly cleared.
So it's only for the here and now.
Exactly. It's strictly for that moment-to-moment essential work.
Yeah.
Which is precisely why AI needs so much of it. It needs this enormous clean workspace to just constantly ingest and process data.
So, what does this actually mean for you? Our mission for this deep dive is to follow that sudden cost spike as it ripples out. We're going to look at 3 critical areas. First, the surprisingly long list of everyday things in your house that are now more expensive. Second, the high-value professional gear that keeps whole industries running. And finally, the unexpected shockwave that's hitting the transport sector. Let's start right at home. When you think RAM, you probably think phones, laptops, sure, but just think for a second. Where else is this expensive little chip hiding in your house that you probably didn't budget for? It's everywhere. And often in systems where we expect, flawless performance, your smart TV, for instance, it needs somewhere between 1 and 4 gigabytes of RAM. Now, why does a TV need memory?
Well, it's not just to store the streaming apps.
Right. It's constantly buffering that 4K video stream. It's managing the operating system, running background updates. If that working space runs out, the video stutters, the remote lags, the whole experience just falls apart.
It's the exact same logic in your car.
The infotainment system.
The infotainment system is using 1 to 4 gigs to run navigation, handle voice control, manage things like Android Auto or Apple CarPlay. You expect to be able to switch between a map, a phone call, and your music app seamlessly. RAM is what makes that multitasking possible without freezing the screen.
And it gets smaller. I just bought a new Wi-Fi mesh node, and I certainly didn't think about RAM costs with that.
But those systems absolutely need memory to handle high-demand networking. A good Wi-Fi router or a smart home hub, like one of those voice assistant screens, they need anywhere from 256 megs up to a full gigabyte just to run the security software, manage the firewall, and handle, say, 30 simultaneous connections without dropping your signal.
Even smart fridges.
Even smart refrigerators, yeah. With their touch screens and recipe apps, they need 1 or 2 gigs of RAM. And when the cost of that 1 gigabyte chip doubles, that cost has to be absorbed somewhere.
And this is where it really starts to matter to you as a shopper. When a manufacturer's chip cost doubles, they have, 2 options?
2 basic options. They pass the cost on to you, or they cut corners and install less memory.
And that second option is the dangerous one.
It is, because that memory doesn't just guarantee speed today, it's about longevity. It's what we call future-proofing. As all software, all apps get more complex over the next few years, they're going to demand more memory. If you buy a device with the bare minimum today, it will feel frustratingly slow much, much sooner.
So more RAM now means your device feels fresh for longer.
Exactly.
So if you're out shopping, we've kind of distilled the key advice from our sources to help you manage this new reality. If you're buying a new phone or a tablet, you really need to look for a model with at least 4 gigabytes for just basic use. But if you play demanding games or you're a heavy multitasker, you should be aiming for 6, maybe even 8 gigabytes.
And for a laptop, especially for work, 8 gigabytes is the absolute modern baseline. It's the minimum to get basic work done. But if you're juggling demanding software, big spreadsheets, multiple video calls, maybe some light photo editing all at once, the sources really recommend jumping to 16 gigs.
And that's where the choice gets tough.
It is. It's the single most effective upgrade for preventing daily frustration, but it's where this price shock forces you to make a really difficult choice between budget, and performance.
That focus on getting the most out of a high-value purchase, it takes us right into the professional world. We're moving from consumer budgets to corporate ones now. We're talking $5,000 to $30,000 machines. And the RAM capacities, they don't just double, they multiply exponentially, which makes the price shock way more significant.
Right. Think about high-end desktop workstations. These are the workhorses for things like 3D rendering, scientific modeling, huge video projects. They need immense working space.
Yeah.
We're talking 32 gigabytes up to 256 gigabytes of RAM.
Wait, 256 gigs? That's more RAM than most small business servers had just a few years ago. Is that genuinely all for active computing, or is that just hardware makers trying to sell more expensive parts?
That's a great question, and it actually gets to the very root of this AI demand. An AI, or a machine learning workstation, which can cost over $30,000, needs 64 to 256 gigs for a very specific reason. Think of the GPU, the graphics card, as this incredibly powerful engine that does the actual deep learning calculations.
Okay.
In that context, the RAM is the massive high-capacity fuel line feeding data to that engine. If you only install 64 gigs for a task that needs 200 gigs of data to work on.
You're trying to run a massive engine with a garden hose. The GPU starves waiting for data.
It's starving, exactly. You aren't just slowing down. You are effectively paying $20,000 for a powerful GPU that's only operating at 20% capacity because it's just sitting there waiting for the next little block of data.
That explains the demand perfectly. Now, you mentioned specialty RAM earlier for these high-stakes applications.
Yes. For any kind of critical or sensitive application, they use something called ECC RAM. That stands for Error Correcting Code RAM. In a field like medical imaging, radiologists use workstations with 32 to 128 gigs of RAM to instantly view these massive DICOM image sets.
DICOM being the standard for medical scans.
Right, it's just the format. And those files are huge. A single silent error in the data feed, a flipped bit caused by heat, or even a cosmic ray, could slightly change a color gradient on a scan.
Which could lead to a misdiagnosis.
Potentially, yes. ECC RAM prevents that by detecting and correcting those single-bit errors on the fly.
So if you're dealing with human lives, or I suppose massive financial transactions, you just can't risk a silent calculation error.
Precisely. Financial trading workstations, which need 32 to 64 gigs, they require that speed and that integrity. A shortage of RAM there costs milliseconds, and in high-frequency trading, milliseconds absolutely cost millions. And we see this in manufacturing, too. CNC machine controllers.
Computer numerical control, the automated factory machines.
Exactly. They use 8 to 32 gigs. That RAM holds the tool path data, which translates the design file into the physical movements of the machine. If that data lags or has an error, the entire part being made is ruined.
So for our listeners making these big investment decisions, what's the actionable takeaway from the price spike?
First, if your workload involves sensitive data AI training, medical imaging, finance, you have to look for ECC RAM. The small price premium is absolutely worth the data integrity. Second, and this is crucial for future-proofing, that multi-thousand-dollar investment. Make sure the system allows for RAM upgrades later. Look for extra DIMM slots.
That's the smart budget strategy, right? If money's tight now, buy the minimum you need, but make sure you can expand it later.
That's it. When the next budget cycle hits, or if prices stabilize, you can add more without buying a whole new machine in 2 years.
Okay. We've covered our homes, the professional trading floor, but now let's talk about how this cost pressure leaves the building and hits the global transport and logistics supply chain. This is where every tiny component cost gets multiplied across millions of vehicles.
And the scale becomes truly immense here. The cost translation is really simple. You double the price of a small chip, and every vehicle that relies on dozens of computers, which is now basically all of them, becomes more expensive to build. It's not one dramatic increase, but the accumulation of dozens of small increases across all the different systems in a vehicle.
But how does, say, a $100 increase in chip costs really translate to hundreds of dollars on a semi-truck that already costs $150,000?
Because a modern heavy truck doesn't just have one computer for the radio. It has distributed control systems, telematics for fleet tracking, engine management, and increasingly complex driver assistance systems. Each one needs its own memory. And we can actually quantify this. For passenger cars, it's a pretty modest bump. It usually shows up as maybe a $200 to $600 premium per vehicle. For heavy trucks and delivery vans, though, the bump is larger, potentially $500 to $1,000 added to the build cost. That's because of the sheer quantity of chips used in telematics, and especially in ADAS systems.
ADAS being those new safety features.
Advanced driver assistance systems, so lane keeping assist, parking assistance, automatic emergency braking. These systems are all about high-speed sensor data fusion and visual processing. They need fast, ample RAM to make split-second decisions based on what's happening in the real world.
And this cost even spreads to public infrastructure.
Absolutely. For rail systems, where RAM is in the signaling, the passenger display is predictive maintenance software, the increase could easily add a few $1,000s across an entire train set. That's not trivial when public agencies are trying to manage tight budgets.
So what's the end result for the user? Does this chip inflation directly affect my shipping fees, my Uber fare?
It creates a few pretty concrete ripple effects. First, yes, modest price rises for consumer cars. Second, higher purchase prices for commercial fleets, which absolutely translate to slightly higher shipping rates or fare adjustments for public transport down the line.
And here's where it gets really interesting for the future. Technology delays. Autonomous and self-driving features need massive, RAM-rich computers. These higher RAM costs could significantly delay the rollout of these features, especially in lower-priced cars. It widens the access gap for safety tech.
We also see the impact in logistics operations, that cloud-based freight forwarding software. It runs in those RAM-heavy data centers. If their hardware costs go up, they might raise subscription fees, which leads to a small but noticeable uptick in shipping fees for you, especially for fast delivery.
And this pressure is forcing design shifts. Manufacturers are looking everywhere to control costs, so they might install less RAM in entry-level cars.
Yes, and you feel that immediately. The car's infotainment screen might freeze if you try to run navigation and stream music at the same time, because it only has 1 gig of working space when it really needs 4. The user experience gets worse, just offset a factory cost.
The industry isn't just sitting back and taking this, though. What are they doing to soften the blow?
Well, they're negotiating huge bulk purchase agreements to lock in prices. More importantly, they're really focusing on software efficiency writing code that just needs less RAM to function. And on the ground, fleet managers are just extending vehicle lifespans to delay buying new, more expensive equipment. The whole supply chain is in a defensive crouch.
So our deep dive really reveals this fundamental, often invisible truth. The AI boom has turned RAM, a mundane commodity component, into this critical, expensive constraint that impacts everything from your smart fridge to the pace of autonomous vehicle adoption.
Yeah, it doesn't look like a temporary blip. RAM manufacturers are signaling that these higher prices are likely here to stay for a while. What's fascinating is their dilemma. Expanding fabrication plants, the fabs, is extraordinarily expensive, and it takes about 2 years to bring one online.
That's a huge capital risk.
It is. They're balancing that massive investment risk against potential windfall profits. If AI demand keeps skyrocketing, they win big. But if that AI training bubble were to cool off even a little in 18 months, they could be left with enormous overcapacity. Their profitability would plummet.
And that uncertainty keeps supply tight.
That multi-billion-dollar uncertainty means they're slow to invest, which keeps supply tight and keeps prices high for everyone.
The true cost of modern digital intelligence, then, is being paid not just in processing power, but in these physical components throughout the entire global supply chain. So the question for you to consider after seeing the profound impact of one humble memory chip is this. What's the next tiny critical piece of hardware? A specialized sensor, a high-purity material, another invisible chip that might face a similar demand shock from the next emerging technology, and once again silently rewrite the cost structure of our entire interconnected world. Until next time, keep exploring, keep questioning, and keep diving deep. Thank you for listening to today's podcast. Please feel free to click on the link in the description below to discover more podcasts.